Good afternoon, everybody. I'd like to welcome you all to this joint meeting with the Computational Physics Group of the IOP. We are, at least for the time being, the Fortran specialist group, but that will be changing, as you will see later. And I think without further ado, I will hand over to Anton, who's going to talk about how to replace common extensions in production codes.
Yes, thank you, John. This talk really, really shouldn't be necessary in 2020 after roughly 50 years of efforts to standardize and make codes portable, but unfortunately, it's still not the case. So what you see are some specific examples, all taken from production codes that we have to deal with, and we still see this in 2020. Some extensions are listed here to do with time, comma where it shouldn't be, real array indices, and various other things. So presumably these were put in those codes either deliberately or by accident. By accident, what I mean by accident is that sometimes people are not even aware when they code that their given compiler processor is allowing extensions. So they were taught to program like this, and they're not really aware that those are
Anton,
not
you're not sharing your screen. Your slides have disappeared.
Huh? How am I not?
There you go. That's perfect.
Yeah, sorry.
Thank you.
People chose to do it deliberately, which is a bad idea because it might be nice at the time, but then something changes and code becomes non-portable. So going into some examples, and if there are any questions, I can answer any comments. I'm sure that there are some people in the call who are very aware, probably better aware than me of these issues. Yeah, so bad idea is because it reduces portability and therefore reduces opportunities for code testing, and therefore lowers chances of finding errors, and therefore also lowers chances for making performance improvements. There's a lot of outdated, unsafe, obsolete code, not always, but mostly. And often when you're in a situation where I am, for example, I have to work with codes written by others, because it's an extension, the original intention is not clear at all, as for example with real array indices. Vendor lock is a very known old issue. So this is a code called Tempo, Pulsar Time and Data Analysis, where they use time, which is an extension supported by GNU, Oracle, Intel, maybe other compilers. It's supposed to simulate C standard lib time, which is seconds from the epoch 1st of January 1970. And at least one compiler does not accept it, doesn't know what it is. Of course, it's not standard Fortran. So in this case, the fix is relatively straightforward. We can declare an external function time and use bind C to basically wrap a original C function. Module probably would be better, but it's a bigger change. And at that point already, as we mentioned a few times, the intention of the original author would be useful to know, but without knowing anything, this is an example of a very basic, simple replacement. I'm not claiming this is optimal, but it works and it's standard code. At the top are 2 lines of standard C, and at the bottom is a Fortran wrapper using bind C, which is basically a function with ISO C binding. Can you see my cursor highlighting things?
Yes.
Okay. And there's your C int data type, and sometimes people forget that import here is needed because this is interface body. And because C int is a module entity, it does not automatically propagate here inside the interface block, so import is needed. The only situation where this might not work is, as far as I could see, Sun Oracle time returns 64-bit integers, so you'll need to use C-long there. Otherwise, this is a standard replacement. Not that hard to do and makes your code portable. ETIME, this is EMAC atmospheric chemistry code. Many compilers support this extension. This is elapsed time from the beginning of program execution. Now, there are many other ways to do program counters. I don't want to go into the details. Just again, I'm showing one example of standard conforming replacement. This is ETIME here, and you can see IBM is mentioned here, and several other compilers definitely support these extensions, but not all. So it returns an array which is split into user and system time separately. There are two, again, simple C functions here, slightly more complicated, and this will work, as far as I understand, only on POSIX systems because we're using POSIX calls sysconf. And then it's the same idea, bind C, and each of those C functions is given a Fortran interface, and that works. So again, I'm not claiming this is the best replacement, but it's relatively easy to do and immediately makes the code standard conforming. As we discussed with Harvey, particularly when it comes to timers, there are many different possibilities. Really depends a great deal on the objective and what things are or aren't allowed in the code. So few opportunities are listed there, from just bare standard Fortran to programming model timers, MPI timers, and several other possibilities. But again, it's not easy to implement any of those in existing code if the original intention, the intention of the original author is not known, which is rarely the case. The same tempo codes, this is something that really was new to me. Comma before output item list. So this comma here, this bit in parentheses is the unit specifier and the format specifier, but then there's comma before the output list item. Presumably this was put in originally by some compiler vendor to be more like print statements, but it does not make any sense. And some compilers, of course, reject this. Problem with this one, that is not easy to automate. A simple parser will not do it. You've got to be quite a clever parser because, like, statement shown here spreads over 3 lines. So you have to find, it's quite a complicated condition you have to look for. And in many cases, I had to do it manually, remove this comma. Reading real into an integer. Now, this is strictly speaking not a problem with the code as it's written, but rather with the code as it's used. So in this particular case, two compilers give two different runtime errors. And digging in, you see that the variable into which this value 35.0 is read is integer, and therefore the runtimes rejected. Now Intel, I haven't seen other compilers accept this. Presumably, again, the documentation doesn't say much, quietly converts 35.0 into 35. But this code, the use of this code is broken, should not be used. And I have no idea what it would do if it were 35.1. Would it still read it as 35, or would it reject it at this point? So it's very unsafe and just sloppy practice. Clearly, this code was not used on any compiler other than Intel, which would which would have immediately highlighted this problem. This is an amazing code for this talk. Theoretical raw vibrational energies. There's a paper listed there. It's a treasure trove of extensions and non-conforming practices. In fact, as they proudly say here, you will need Intel compile Intel MKL. And indeed, if you do not stick to those, you will get all sorts of crazy troubles. So variable format extensions, I understand originally comes from DEC, then obviously DEC Fortran came to Intel, and Intel supports this. This comes from a need by the programmers to include variables inside the format expressions, which is not allowed, not even in the current standard. So extension allows you to do it, but it's rejected by at least 2 compilers. The fix, in simple cases at least, or maybe I would go as far as to say in all cases, really, is just use internal write. So instead of this in red, I'm replacing it with writing into this character variable, and then this character variable is used as the format. This is standard conforming Fortran and works very well at the expense of 1 extra variable and 1 extra line. So really no excuse not to use it. Entity redeclaration. Now, this is really strange. This is a crazy code. I would not have imagined that any compiler would accept this. IK is a common variable to say some sort of integer kind, parameter. Yeah, the parameters are not a variable. And then they declare a variable with the same name. And amazingly, quite a few compilers accept this, and at least Intel gives a warning, but the GNU does not even issue a warning. I presume that when the compiler hits this point, it notices that there's a variable with this name, parameter with this name already, and uses some internal redeclaration, but it's still wrong, because of course later on in the program you will not know what is meant. I'm saying the error message here in this case it's a Cray compiler. It should, I think, use associated rather than host associated. I'm not showing the full code, but that is correct. It should use associated. And this is the rule of the standard that it violates, and the only fix is to rename, really. It could possibly be done by a script, but unlikely, because it might not be possible to distinguish easily the use of this parameter from the use of this variable in the code. And again, because the original intention is not clear, it's hard to know how to be 100% sure that the fix was correct. This looks like a benign thing, orphaned line continuation symbol, but still it's not a valid Fortran. And again, there's no need for it. This probably comes from automated code generators of some kind, which are not very well written, and they spit this continuation symbol even though there is nothing to continue. One compiler rejects this, the other gives a warning, but it's a broken code. It violates this rule. This probably could be done with a script, although again there might be some corner cases, so careful check would be needed. Format specifier without widths happens quite often actually in many codes, because it goes back a long time to the users demanding much more flexible specifiers, format specifiers, and various compilers have accepted this form for a long time without giving the widths, and what is now of course standardized as 0 widths. So changing I into I0 would immediately make this code standard conforming. Very easy fix and no side effects as far as I can see. There's nothing is lost here. Long lines, of course, you could say is really completely benign. I shouldn't be even mentioning this, but still it's an annoyance in a very big production code. Plus, of course, the readability is very bad. So anyway, at least there are compiler flags. There's one given for GNU and one for Cray to accept long lines. I can't remember right now if the latest standard says could be unlimited line lengths or unlimited number continuation lines. The limits have been extended substantially, but I just think it's a bad practice to have lines with crazy lengths. Now this probably comes from just poor knowledge of the language and confusion between logical and relational operators. So here this line is rejected because the quantities here are logical, but the operator is not. So in this particular case, the fix is simple. We have to change the equivalent EQ or this equal sign into dot EQV dot. I imagine there must be quite a popular error, and I don't know if many other compilers accept this, but I wouldn't be surprised if there are other compilers apart from Intel that do. Similarly, mixing logical and integers, well, this potentially could be very dangerous practice because it relies on some not very well-defined interpretation of integers and logicals and vice versa for comparison purposes. So I'm giving here some rules that Intel and GCC use, how integers are interpreted, odds as true and even as false. But again, it's not foolproof. The fix here is not foolproof because the original intention is not clear. I'm writing this here, doing remainder of division by 2, blah, blah, blah. But perhaps something else was meant there, not just the yeah, so the original comparison here, my fix is only based on my understanding of what was meant by that comparison, but I'm not sure it's completely foolproof. Function declaration with no brackets. Well, I don't know how much it costs to type 2 more characters and have it conforming code. Perhaps originally it was a subroutine and then it became a function and people forgot to add the brackets. So one compiler rejects this and it violates the syntax rule. Fix is trivial. So it should be done, really, no excuse. Now this comes from a code with heavy pre-processing. So probably the error is not in the Fortran itself. The error is in preprocessor that somehow produces this plus minus following each other. But annoyingly, some compilers do accept this. I wish every compiler would reject this. It's a clear inconsistency with Fortran rules and with the mathematical rules, but some compilers do accept. One with a warning, some without a warning. So fix is obvious, of course, but it would be silly to fix Fortran if the error is in the preprocessor. This is a recent thing, but it happens very often. assumptions about the numerical values of the kind, although here it's not even that, it's not even the number 16 is assumed, it's that this particular processor simply does not support an extended precision kind, and therefore it's it it's not only is code is bad, is actually it might work on some systems, might not work on the other systems, and it might not deliver what the author thought it would do on some other systems. So 16 is not guaranteed to be 16-bit real, and also it's not guaranteed that this kind will be available. So these are two problems I'm listing here. Simple code that people can use to check for whether this is extended precision is available, either using real 128 parameter, which is in ISO Fortran env, or selected real kinds. Selected real kind has been available for a very long time, real 128 for a long time, maybe not as long as that. So running with a particular processor, you get that it's not supported, and therefore it should not be used. There are many other what Harvey calls pain points when we have to deal with codes coming to us from other organizations written by other people. Uncommon build systems which just might not work. Nothing really to do with Fortran specifically, but something very obscure combination, not the standard make or even CMake, something very far from that. Sometimes people abuse the extensions. There's some convention, although it's not a standard, but it's a convention. So for example, capital F usually means the source code must be pre-processed, and 4 typically would mean fixed form. But sometimes these conventions are not followed. Sometimes they're mixed, and that makes our life quite hard. Custom preprocessor traces and builds also complicates things. Compiler directives, a lot of them are very, very old, and I'm giving here a snippet from a particular code with 3 directives following each other. In one case, even the sentinel for directive is, and I have no idea now whether it's a syntax error or there really was some compiler that accepted this different spelling of directive. OCL, I believe, coming from some Japanese compiler, but hard to know. The question here is, has anybody ever tried to standardize compiler directives? Probably not, I imagine, but maybe. And then the usual variation formatted outputs, formats, least directed IO causes trouble because hard to compare results. And some variables are just best to avoid. Well, if this is O2 or 02 number, or is it L1 or is it I1, just very easy to make mistakes and again makes life harder. So very simple conclusions are people should avoid extensions if at all possible. And really there's, I think, no excuse in 2020 to be using extensions still, apart from laziness and inertia. And in many cases, as you saw, the effort in fixing extensions with standard conforming code are minimal. Use maximum compiler diagnostics to expose extensions and non-standard usage, and it might be actually leading users to realize that there are bigger problems in the algorithm. because it forces people to think about the origins of those extensions. Replace extensions with standard conforming code. It's a key message of the talk. And checking with multiple compilers, of course, enables immediately all the other benefits. As soon as your code is portable, then it allows for bigger, much better checking, compile time checking, runtime checking. It allows for better analysis of the performance and so on and so on. So that's it. Thank you for your attention. Let me see if there are any questions or...
There's a question from Clive, if you can see it.
No, I can't see any.
So Clive is suggesting it's better to replace the standard lib time function with the Fortran intrinsic date and time.
Yeah, could be, except I don't think the return value from date and time is exactly the same as expected here. But sure, date and time with few more lines of code could be used to extract the useful data. I cannot really see anything on the chat or comments.
So there's another question. Thamos, oh God, my screen's a bit small. Have you been successful in updating any of these codes? Like,
Well,
presumably, are you feeding back these fixes to the authors, for example?
yes and no. It really depends on many complicated factors. We definitely have fed some comments back upstream. Sometimes the upstream is extremely unresponsive or defensive. I guess if people in 2020 use codes which they haven't touched since forever, yes, they might feel a bit defensive. They just don't want to touch those codes at all. There are other upstream projects and organizations who are much more receptive and they're willing to discuss changes. But of course, here we're not talking about major algorithmic changes. It's a very simple requests. If you change this for that, then immediately you can try to run your code with 2 or 3 or more compilers, which hopefully the attraction of this is obvious to the users. But so it's a mixed. The answer is it's a mix of everything. Oh yeah, I can see the questions now. Yeah.
Okay, thanks very much, Anton. I think that's it on the question front. So bear with me while I make Ian a presenter. Hi, Ian. You're muted.
Thanks very much. So can everybody see this now, John?
We can see your background screen, the interesting spider.
Oh, right. Sorry, let me...
Oh, sorry, hang on a minute. There was somebody with their hand up in the, presumably it's from the last session.
Okay.
But I don't know. Hang on a sec. Yeah, I'm not seeing any hands up. That's the... Paul, sorry. You should be able to speak.
Yeah, I took my hand down after you went over to
sorry.
Ian.
Oh, sorry.
It's all right. Just a couple of remarks for Anton. First of all, with GNU, unary followed by arithmetic operators, if you set the standard flag, you get an error. So the extension is expunged by insisting on a standard. And second, the real index, it's equivalent to int.
Okay.
I'll make sure that last one's documented.
Okay, cool. Thank you, Paul.
And I'll work through the rest.
Wait, no, you don't need to work through anything. The intention is that users work through their code. It's not.
Oh, I understand that, but a lot of these things are not getting flagged, are they? I just want to make sure. I want to make sure you get a warning if indeed this comes up.
It's possible. I haven't done an exhaustive search, of course. It's possible that setting some very strict flags would have highlighted all or many of those. I cannot claim I've done that.
Yeah. Okay.
Okay, Ian, you ready to go?
Yep. Can people see this, John?
No, I can't. I'm only looking at the spider. Your backdrop again.
Oh, that's interesting. All right. Sorry,
Are
let
you
me have I've got show screen.
You could just try sharing the app, just the whatever application you're using.
So does that come up?
That works, yes.
All right. There are essentially three components to the talk. Jen and I have been working through several standard changes. So the first one that we worked with was the change from 60/60 to 77. And what we found with that one was within 2 to 3 years of publication of the standard, you had readily available the standard-conforming compilers. So that the transition essentially was pretty straightforward. And you could portably move your code around. At the time that Jane and I were involved in the transition from 66 to 77, we both worked within the University of London and within individual colleges. At that time, the University of London was a single institution, and there was quite a lot of collaboration, essentially, and use of common facilities. So I worked at Imperial College, which was CDC based, but our user community also used the University of London Computer Centre, which was CDC and Cray based. Jane was at Chelsea College, and a lot of the other colleges used other different hardware and software platforms. But by and large, by 82 or 83, code was pretty much portable, basically, across all of the London colleges. The next transition that Jane and I got involved with was the transition basically from Fortran 77 to Fortran 90. And this was the first one where there was a bit of a delay. And the standard was published in 1991. But what we actually found essentially was it took 3 or 4 years essentially before we had reasonable widespread availability across a range of hardware platforms of standard conformant compilers. So essentially, again, what you're looking at is portability of code. So it took a while essentially for that to actually happen. Fortran 95 came along, and this was relatively straightforward. And again, within 2 or 3 years, essentially, you had a reasonable degree of portability of your code. The real one that actually changed everything was the Fortran 2003 standard. This was actually published in 2004, but this is where Jane and I found essentially that what we actually hit with this standard was quite a lot of problems essentially in portability of code. And this was due to the fact, essentially, that what you've actually got is quite wide differences, basically, in the implementation of the features in the language. So what we ended up doing was eventually creating a table, essentially, which was based on John Reed's document. So this is available online. So you can get access to it basically from the WG5 site. So that was the first one that we actually used basically as a feature list. And the people who got involved in providing this information for this was Bill Long at Cray, Van Schneider, Tobias Burness and Brooks Moses for the G-Fortran team. At that point, G95 was under development, and we had input from Andy Vorts, and NAG were involved, and they provided us information. And that appeared, the first publication of that appears in the April edition of Fortran Forum. And what we tried to do is to provide a history, essentially, through publication within the ASM publication Fortran Forum. So if you wanted to have a look, essentially, at what's happened historically, there is a permanent record through what's available in the ACM digital library. You can subscribe to that for $20, and you get access to the Fortran Forum newsletter. Eventually, we got input from IBM and from Stan Whitlock of Intel. So what you're actually seeing, essentially, gradually is more and more people providing us with information, basically, about the progression that we're actually seeing, essentially, to the implementation of 2003. But if you wanted portable code, you needed to be very careful about what you were doing, essentially, to actually make sure that the features that you were actually using were available in the compilers that we're actually using. So what we then see is succession of revisions. Richard Main then made some input, and these are two features which weren't in John's original article, but they are actually quite useful. So this is allocatable scalars and allocatable character length. So what we're actually seeing gradually is an increase in the content in the tables. So that what you can actually do essentially was reliably use more and more of the features at the standard. We eventually started working with the Fortran 2008 standard, and again, that one's available from the WG5 site. And I'm not going to go through all of these. What I'm going to move to is the first table. So let's have a look at it. So we've obviously had input quite regularly. So this is the Fortran 2003 compliance table. And what we actually find essentially is this version of it, we've now had input from all of the vendors there, Appsoft, ARM, Cray, Fujitsu, G-Fortran, IBM, Intel, NAG, NEC, Oracle, and PGI. And this is effectively the first time that we've had information basically from that set of vendors. So now you can actually make a reasonable attempt essentially at generating portable code. And the two features which were the latest to be implemented were parameterized derived types and derived type IO. So they were quite late basically. But what we actually saw essentially was by 2012, 2013, basically a large part of the vendors had actually implemented quite a significant portion of the Fortran 2003 standard. But what we actually found was if you wanted to do object-oriented programming, then essentially robust implementations of it, of the features basically involved in that, weren't really available until 2012, 2013. So that's a bit of a disappointment, basically. Then what you're actually looking at essentially is 8 or 9 years essentially since the publication of the standard. I'm going to scroll down to the summary table. So this now summarizes what we've actually got. So the AppSoft compiler is still behind. I'm not sure basically when the AS vendors will catch up. But as you see with the majority of the vendors now, ARM, Cray, Fujitsu, G-Fortran, IBM, Intel, NAG, Net, Oracle, and PGI, you've got pretty much complete implementation of the Fortran 2003 standard. But now what we're actually looking at is the date on this article is 2019. So it's roughly 16 years since the publication of the standard. The next standard that we're going to look at is the 2008 standard. So we started making a move to actually provide information about this. The two major features that most people were probably interested in was submodules and co-arrays. And what we've actually got with this, we've had to split. We've got a table which basically describes the features. Again, it's based on an article by John Reed. So John provides most of the information for this. As I scroll down, we also added information from Annex C of the Fortran 2018 standard. So basically, these are features that were new in 2018, but not originally listed in the introduction as being new. So Mark and Cohen basically provided the additional information essentially about this, and this was incorporated into this table. So we retrofitted it, if you like. And this is the implementation summary. And now what you've actually got, obviously, is quite a problem, essentially, if you're looking at portability. You have to be extremely careful which features in the language you're actually using, essentially, to achieve portability. So if I scroll down, eventually we come to a summary table. So what you've actually got with this is a summary, basically, of implementation of the 2008 standard. So this was as of the autumn of 2019. So as you can see, essentially, you do have some issues with this if you're looking at portability, and it's quite hit or miss, essentially. You've got to be extremely careful what features you're using. There's some errors in the table, which is basically due to the fact that the counts basically are generated by Excel, and they're obviously wrong. The next thing we've got is a TS. So that was that one. And then finally, we get to the 2018 feature list. Now, what we've done is we've retired this table because basically now most vendors actually support all of the features of the 2003 standard. What's interesting essentially is the length of time essentially taken to actually provide pretty comprehensive implementation and also reliable, non-buggy implementation of it. Some of the features are still a bit flaky. So if I close this one down and we move to the next one. So basically the next thing that Jane and I did was basically drop the 2003 table, and we're now concentrating on 2008 and 2018. This article appears in the August edition of Fortran Forum 2020. It's not been published yet. The editorship is now passed over to Damien Rousson, and he's currently got this in production. I've been in contact with the ACM, and they're waiting for Damien to actually produce this. If you want a copy of this, Jane and I can actually make it available. So this table, we've had used several sources to provide the features. So there's N1828, which is available at the WG5 site. N1891, which was it superseded it. That was published in 2011. Additional features were taken from Annex C of the 2018 standard, and then Van Schneider raised the issue basically about this one. So now what we've actually got is a table that describes the features. We've added an artificial numbering scheme to link the tables. So what you've now got is the 2018. So this is similar to what we had previously, but it's been updated and corrected. So if I scroll through this. So you need to actually cross-link to the various tables to get the full lot. So here's the implementation summary. And again, what you can actually see, obviously, is pretty patchy. So even in August 2020, achieving portability here is quite difficult, depending on the features that you actually use. There's a summary later on. So this is the vendor summary. So this was a vendor summary as of earlier this year. So what you're actually seeing essentially, again, with the 2008 standard, it's quite difficult essentially to achieve reasonable portability. So what you've actually got with this is Intel and NAG are now have successfully implemented most of the standard, and also HP, obviously Cray, have done a pretty good job as well. So those are the three major compilers that implement most of the standard.
Ian,
Yeah.
Ian, we're still looking at the other document. You must have switched documents.
Oh no, I'm really sorry about that. So what happened there then?
We've all been abandoned on the previous document. So
I'm sorry, I'm not sure quite what happened there.
I think you just need to share that one explicitly.
Oh, I apologize for that.
No, that's quite all right. We should have flagged it up earlier.
All right. So can you see it now?
Yes.
All right, let me go back. I apologize for that. I had no idea it was doing it. All right, so basically what Jen and I have done is we've dropped the 2003 completely, and we moved to 2008 and 2018. So what we've actually got with this is you can more or less assume essentially that what you've actually got is full-blown 2003 compliance. Let me just go through the summary then, for the frequency summary. This document will be published in Fortran Forum at some point, but if you, I mean, Jane and I will make this available, as that hasn't been published yet. So from the point of view of the meeting and people interested in this, we will actually make this available. And again, it's based on several documents. Let me go to the summary side of it. Sorry. So this was the thing that's slightly disconcerting, essentially, is the delay, essentially, between the publication of the standard and complete implementation of all of the functionality. So what you've actually got with this is Intel and NAG and Cray, essentially, are effectively pretty good, essentially, with their implementations. But if you're using some of the other compilers, then obviously you do have some issues regarding portability. It would be interesting to see what the rest of the vendors actually do. With the 2018 support, obviously, this is so new that Jane and I don't really realistically expect many people to have done much on the implementation front. But it's interesting that the there's a beta out for the Intel compiler at the moment, and they seem to have done a pretty good job of implementing. So with this one, Jane and I have only had information from Hewlett-Packard, Intel, NAG, and NEC. So basically, what you're actually seeing here, I presume at some point we will get information from the other vendors. We're reliant on the vendors providing us with the information. We then integrate it into the tables. So this is the summary table that we've actually got. So Cray have done a very good job on the 2018 front. Intel are more or less there with the beta, and NAG have done a pretty good job as well. I'd like to finish there, basically, just throw it open for questions.
Well, there's been no questions on the little questions box, but I'll ask the usual question, and that is, are the compiler vendors not implementing these because it's difficult, or are they not implementing it because they're just not seeing any demand for these features?
I think it's a mixture of both. Certainly, as a quote programmer, I didn't have a lot of interest personally in parameterized derived types and derived type IO. I mean, I can't talk about other people, but as I could actually achieve you know, something sensible, basically using other features in the language, I wasn't that bothered. I mean, I can't talk for the other people on the Fortran committee, but from my point of view, those are two features in 2003 that I wasn't that bothered about. And Jane and I certainly didn't see a lot of interest amongst the user community when we're training, basically for information in that area. And they do seem to have been particularly difficult to implement well. I mean, Paul might like to talk about that with the G-Fortran compiler.
Okay,
yes,
sorry.
in fact, there are three different drivers for implementation of new standard features. One, of course, is partially demand, at least on the G-Fortran. The majority of people are actually programming in G-Fortran and are implementing the features that they want to use. It goes a little bit further than that. There is a kind of a moral drive to implement as much of the standard as possible. Then there's a resource limitation, which I think is probably the case for the majority of vendors who haven't responded to your latest collection of compliance information. And then finally, at least with the 2003 standard, there's immense technical difficulty. I mean, the 2003 standard was a huge change. And you say that we're more or less there, but as it happens, over this last weekend, I was working on a bug on unlimited polymorphic objects, which took quite a long time to fix, but it is now fixed. You're exaggerating by 1 year, by the way, with the length of time it took, but Fortran 2003 was published in 2004. So yeah, a mixture of reasons for non-implementation.
Mm-hmm.
Hi, Ian. Can you see the additional questions in your question box?
Oh, let me just have a look. No, I can't. I'm sorry.
So
I cannot see anything either.
Oh, right. I've got something. Sorry.
yep.
I've got a question from Cray. I think that the current Cray compiler is 2018 performance, but I have some checking to complete. Do I send the updates to Damien? No, Jane and I maintain the tables, but Damien is now the editor. So what we do is provide an update to the table and then send it to Damien as the quotes editor of Fortran Forum. But we wouldn't get him to do all the donkey work in the construction of the tables. So hopefully that answers Bill's query. We don't track the quality of, this one is from NAG. We don't track the quality of the implementations in any way. I mean, the only thing that we do is try things out. I mean, we do know that some things that we try using are buggy, but what we do is then file a bug report with the compiler vendor. Whether it's wise or not to test the vendor's claims, basically, I just think you file a bug report. I mean, that's all you can do. I'm sorry about that one. You just have to throw it back to the vendor. But Jane and I do know that some of the features aren't that easy to implement. And I'd agree with JM Escatar. Vendors don't implement it because there's little demand. And so that is an issue. Yeah, I'd agree with that.
Well, it creates a catch-22 situation that,
yeah,
if it's not there, you can't use it, and it hinders your portability from the get-go.
Yeah, I'd agree. I mean, it is a difficult one, and also if it's not portable, I mean that's one of the kickers that Jane and I find. I mean, do you introduce something to a feature that they can't actually use with their compiler?
Well, G4tran's coming under a lot of pressure from the rather complete compliance of Intel in particular now. There's a tendency, as the Steve Lionel's survey found, for people to use Intel and G4tran as matched pairs. When they do their coding at home, they use G4tran, and they use Intel at work.
So there is pressure on you, but it's a resource issue, isn't it?
Absolutely, yes, since we're volunteer-based, and we've failed absolutely to raise any significant amount of money to support G4tran.
So there's a question that's been posed: is G4tran 8.2 the latest?
No,
What does
basically.
G4tran?
Sorry, let me clear that out of the way. No, that was the latest information that I had from the G4tran crowd. Again, we normally wait for the vendors to actually provide us, but I mean, I do know that Damien and other people within the G4tran community were going to do something, but I can't remember what's happened to it. Was there some sort of GitHub thing you were doing, Paul?
Well, we had a dip in maintainers, basically, although we've recovered somewhat,
Yeah.
including myself. I simply couldn't afford over the last essentially 6 to 9 months to do any support of G4tran. So you're one of the people that, sorry, I was one of the people you wrote to, Ian, asking for this, and I simply didn't respond because I've been out of G4tran completely until relatively recently.
Well,
so I do apologize.
No, it's fine. I mean, I knew Damien was coming up with something because he's given me some input. He wanted, so it would have been Damien with the Open Co-Arrays project. So I think that he was keen on doing something, but you know, I haven't been in contact with Damien for a while, so I don't know, you know, what his status is.
I'll get on to him and find out. He's probably in a smoky cloud at the moment.
Well, he's looking for a job, so I do know he's probably a bit snowed under. Yeah, you're probably right with both of them.
Yeah.
The last question was to do with LOVN. Well, that's basically down to people actually providing me with the information. I mean, I'm not sure what's going on in that area. So is it predominantly ARM that are going down the LOVN route, or are there other people involved with it?
As far as I'm aware, ARM is the main driver of this, but I gather as well that Intel are moving in that direction.
Yeah, I'd heard that as well. So I can't really comment basically. So there was a Michael Vassar again. I'm not exactly sure what's happening in that area. But as Paul said, Intel apparently are making some moves in this area. But the dominant one would be ARM. But I don't know what other people are doing. And again, it's down to the vendors who provide us with information.
And
So
I gather there's an implementation of GNU on LLVM as well.
yes, I understand that's happening as well. Yeah.
The GNU front ends, I should say.
Yeah.
Yeah, so Bill just made a comment there about NVIDIA have obviously bought PGI. Well, they're buying everything, aren't they? And so they are keen on LLVM.
So NVIDIA, have they bought PGI?
Yes.
I thought it was ARM they were buying.
Both.
Oh, right.
Well, they bought PGI quite a while ago.
Yeah.
All right, so maybe we should drop this one out.
Well, in fact, the PGI, modern PGI compiler is just called NV Fortran.
Oh, so this has been superseded then.
Yeah, it's no more.
All right, so I should contact NVIDIA for this thing. I don't have any NVIDIA contacts at the moment, so I'll have to, Jane and I will have to look into it then.
Okay, I think that's it. I think we've answered everything. I don't see any hands up, which is good. I haven't missed anybody.
Right.
So what I propose is we just have a quick 5-minute break and just resume at 1:15, if that's okay with everybody.
Yep.
Stretch the legs a little bit. And I'll see you all at 1:15.
Yeah, sure.
Right.
David, I don't know if you're still there. Do you want to put your presentation up?
Yes, I don't. I can. Should I take the full screen? Would that be the thing to do?
Yeah, I mean, it depends on privacy issues, I suppose.
Then I can't see any of the Zoom instructions. Is that okay?
Yep. I mean, you can share as what you like. I mean, that's fine. That looks good.
Yeah. Okay. Yes. So I can see both my screen and they've got some controls as well, some control windows.
Well, as long as you're happy with that, it looks good from my point of view. Brilliant. Fantastic. Thanks.
We're running slightly behind time, but I take it that doesn't really matter.
No, I don't think so.
Bill Long, are you still with us? No answer was the stern reply.
Okay, I think we're ready to go. David, are you ready to go? I think.
Yeah, you're ready to go. Okay.
Yeah, I
Fine.
think we should go now. It might be confusing that to some people, but John Reed is the webcam at the top, not David.
Okay, shall I start then?
Yes, please do. Yes, thank you.
Right. Fortran Specialist Group was formed 50 years ago this year, and I'd like to describe the environment which caused its foundation, and then discuss the activities in the first few years. So if you look back to the late 60s, there were many scientific languages around in the late 60s. If you think of Gene Sammett's book, published in 1969. It was quite a large volume on the history of programming languages, and programming high-level languages has only been going a dozen years or so. In Europe, there was a preference for Algol-like languages, more elegant, more powerful. And people tended to rather look down on Fortran, which was seen as rather crude. But then, and in those days too, mainframes cost millions, and software was considered cheap or even free in comparison. And people gradually became aware that there was a great deal of useful software written in Fortran, mathematical libraries, statistical libraries, packages, circulating particularly in American universities and research labs, which were available for free. So interest was growing in Fortran, and a conference on the use of Fortran applications was held in Edinburgh in 1969, attracted 160 people from all over the UK, and about half a dozen people had come from the continent, Germany and Holland and places. So interest was growing. Oh dear, gone wrong again. Yeah, so scientific computing in the late 60s, the public sector was generally required to buy British. A few people avoided that rule. I mean, ULCC got a CDC. Places like Aldermaston and Harwell were allowed to buy American. But KDF9, Edinburgh University, which is sort of ahead of, had facilities perhaps in a medium, not as good as others and was, but better than a lot, had a KDF9, and that offered only Algol and IMP, which IMP was an extended Atlas autocode, a block structured language. Input was, most people had input was 8-track paper tape, and a few people got used to the use of punch cards. 8-track paper tape was a devil to edit. The only advantage of 8-track paper tape was if you dropped it, it was stayed in one piece. If you dropped the pack of cards, you might be in trouble. Edinburgh was a widespread university, departments up to 2-3 miles apart, and some much more further away than that. And a van collected input and delivered the output to departments. So you might get 2 or 3 runs a day if you were lucky. Fortran was available via an overnight van service, took cards in the evening and brought back listings in the morning to the National Engineering Laboratory. Such was the mismatch between demand and supply of these small machines that even computing stuff on site rarely got more than 2 runs per project per day. And obviously, if you're using the overnight van service, you only got 1 run per project per day. Remote access via telephone was just coming into use. So what caused the Fortran group to be set up? The first Fortran standard came out in 1966, and of course it was the American standard. And under the rules, which are still obtained, by 1970, it was coming up for its 5-year renewal or revision. Most vendors by this time had gone on to something called Fortran 4, which is Fortran 66 plus various extensions of the sort Anton was just talking about, which caused slight problems. But because this was an American standard, the Fortran group was formed to be the focus in the UK for gathering opinion and then communicating these to the standard body, which is the USA committee. And the ANSI committee had the sole responsibility for the entire world of producing the Fortran standard. There was no formal arrangement for international collaboration until a few years later. And indeed, as an aside line, it was two FSG members, Brian Meek and David Hill, who were largely responsible for causing that change to international collaboration. So remember that 1966, 5-year revision would have led us to 1971. In August of 71, XCJ3 was in the midst of processing 153 proposals, and still a lot more to come. And yet, in 2 months later, the chairman was able to say the job is now nearly finished. In fact, development work on the standard concluded in 77, and the standard was published a year later, and it never actually formally received ISO status as a standard. It was called a recommendation for some reason. The group started collaborating, Fortran group started collaborating with J3 in 1971. A member of the J3 committee came to a large users conference in Pisa, and from then on, we met in Pisa, met some members of the FSG, and from then on there was regular communication. Still, the responsibility lay with the United States, but we were able to they sent regular minutes, and we were able to comment on what they were doing. And as a reminder, on the bottom there, Fortran 77, the ANSI Fortran 77, came along with a subsidiary standard because it was worried that Fortran 77, there was concern that Fortran 77 was too big and too difficult to implement on a lot of the hardware that was around at the time. And even then, there was another standard put out by ETIME that was between the basic and the full Fortran 77. So there's a lot of concern that things were going a bit far, and that not all the hardware around at the time would be able to cope. And just a reminder that when they said it always takes longer than planned, the same thing happened later when Fortran 77 was due for its renewal, and the chairman of the FSG was able to say, going to be completed by 1982, and as everyone knows, it went on and on and on, and finally became Fortran 90. So what happened when we're moving on from Fortran 66? First of all, generalized subscript expressions. Fortran 66 had extremely limited subscript expressions. You could have a constant times a variable plus or minus a constant, and that was to fit in with the IBM 704 hardware. Anything more complicated, you had to put into a separate variable and then use that variable. Mixed mode arithmetic, formally there was no mixed mode arithmetic. You had to use conversion functions to add an integer to a real number. If construct, there was the arithmetic if was the basic if construct, but and there was a logical if, an if and a single statement, but the if then else was added. Characters was a total mess and a real inhibition to portability. People had to keep characters typically in integers, but they could be kept in any numerical type or even a logical type. And people kept them in double complex wasn't officially a standard feature, it was a common feature of Fortran 4, and so you could get a lot longer character type. So character type was introduced. There were only 3 dimensions in Fortran 66, so 7 dimensions were allowed. Some restriction on do loops relaxed. Expressions in output lists, including character expressions, that was a great facility to be able to, instead of putting characters in the format to get them to be printed, you could put them in the output list, including the characters, of course. And there were new facilities for input-output, especially, as you see there, 3 formats of data, namely direct access and ability to open and close files. Now, in some ways, things might have gone too far. The alternate return was quite popular. It was quite well adopted in the early 70s by vendors. I just looked up it, by the way, there was a paper in Datamation in 1964 which looked at the output from 16 different vendors who had between them 43 different compilers, so that the portability could be quite a problem. And this also mentioned that in the early 60s, IBM itself had 8 different vendors, 8 different compilers to cope with sometimes 2 or more different compilers on the same hardware, but more often than not, different compilers for different hardware. But very rarely did the language specifications match up. So anyway, going back to alternate return, this was quite commonly available in so-called Fortran 4. But then in 1972, IBM discovered structured programming and decided and recommended that all programming should be reduced to 3 structures: looping, well, straightforward, and whatever the other one was. But go-tos were definitely out, and an alternate return was a form of a go-to. So, although this was approved by J3, added to Fortran 77, it only relatively, very nearly 16.9 escaped a vote to delete it in 1977. But as soon as it was in Fortran, so it was in Fortran 77, but it's been deemed obsolescent ever since. Another one, which is generally regarded as a terrible mistake, real and double precision do control variable. That was in Algol for some reason. Someone not realizing the power of floating point arithmetic. It was not generally available in vendors Fortran, but it was thought in the development of Fortran 77 that we should follow Algol, since Algol was considered to be a good thing. Most FHE members were against, and it was immediately deemed obsolescent and then deleted in all subsequent standards. And then another possible move too far, the entry statement. The entry statement is copied straight from assembler language, really. It was widely adopted in the 70s. Fortran specialist group members had a vote on it. Some were in favor, but most were against. But it got into Fortran 77, and it survived until Fortran 2008, and it was deemed obsolescent then. So, meanwhile, For Fortran 77, there are a huge list of things which were proposed and not adopted, and conditional compilation was asked for then, and it hung around for quite a long time before finally being adopted and then dropped again. Macros were never equally. Lowercase alphabetics were not adopted simply because the hardware was not generally available to support it. The complex format field description, alphanumeric statement labels, which would have caused chaos in parsing. Names longer than 6 characters did eventually get in. Dynamic storage. Well, people were scared of dynamic storage being, well, even quite elementary structures were beyond the capability of the hardware of the 70s. So dynamic storage was considered out of action. And then quite trivial things do not require labeled column blocks with the same length, which most people did, but that was rejected. And then oddball things like implied multiplication after a right parenthesis, like as in mathematics. There's total confusion about do loops in the 70s when the first limit was greater than the second limit. Should it be executed once or ignored and so on? That finally got sorted out, thank goodness. And then another oddball thing, negative IO unit implies backward operation. So, and on and on and on. All this stuff is on the FSG website, if you care to plow through it and have a look. So that leads us up to, so meanwhile, what else was the Fortran Specialist Group doing? Well, working parties were set up on language extensions, and that sort of folded into there were 1 or 2 language extensions and comparison documents produced in the early years, and that gradually folded into the dialogue with XGJ3. Mini computer Fortran, that almost died. As so often with working parties, they start off with great enthusiasm, then people find they've got day jobs and other things to do. So defining Fortran for many computers, that kind of faded away. Free format, that was free format of programs and free format of data. Free format of data, I could not find, they've produced a written report. Looking through all my papers, I could not find that report, but I know it got sent off to J3, and that the chairman of that group had a useful dialogue with J3. Diagnostics, that was a really high-powered group. It had 3 professors and 1 other person, I'm not sure her status, but again, that didn't get very far because people found they had more useful things to do. So those all faded away, those working parties. 71 onward, we had the dialogue, and 75 onwards, we became much more concentrated on presentations on Fortran, on libraries, on applications, tools that are available. There were a great emphasis on structured programming tools in the late 70s, with checking tools to make sure you stay to the standard, or structured programming tools to translate better structured Fortran into Fortran that could be compiled. So from 78 to 93, we changed more to discussing Fortran-related matters. From the development of Fortran 90 on, after 77, several members of the Fortran group joined the ISO ISO group W5, and a few also joined the US committee. And John Reed was there, and he was secretary for a time. Laurie Schoenfelder, Miles Ellis, and possibly one or two others. Certainly, one or two of us were able to make occasional visits to J3. So the emphasis changed with regard to standard development. Then meetings, FSG meetings continue, typically 4 per year, with regular reports on what was happening. And we held Fortran forums quite a lot, typically when there were a large number of members of J3, American members of J3 in Britain for one reason or another. And these attracted very large audiences, or what I think we can consider a large audience, 150 people. And members came to the meetings to learn what was happening in Fortran. It was no use looking in Computer Weekly to see what developments were. Computer Weekly and Computing newspaper looked to us to provide information on what was happening. So meetings were held mainly in London, but from 1980 onwards, occasionally held outside London. So that map shows where they were, mainly in London and Thames Valley. The ones further north was Jodrell Bank and Salford University, and one or two were held in Edinburgh. And there was, the BCS had a very forceful regional officer. BCS regional officers didn't last very long, but there was a very forceful Scottish one. And he wanted to try to set up a Scottish subgroup, and we held one meeting in Glasgow, and I'm afraid that was it. I rather think BCS found the regional officers were exercising too much initiative and rather got rid of them. So then the internet came along, and this shows the effect of the internet, shows how many meetings we had per year, up to 93. Green shows ordinary meetings, typically 4 a year, typically in London, and the blue shows the formats, the forums. So in 1994, we decided to go, because information could now be passed around much more easily by the internet, decided to go to one meeting a year and special meetings for 2002. The special meeting in 2002 was to consider requirements for the next Fortran standard. 2007, that was a very successful meeting to commemorate the 50th anniversary of the first Fortran compiler, and we've had a few special events since. This chart doesn't really work, does it? This was decided to show, trying to show how mailing lists came in, and I say it doesn't really work because red was meant to indicate mailings. Royal Mail has always been red. Archives sometimes thought of brown and sepia. So the FSG mailing list started in 94, and the document archive also started in 94. Those are both Miles Ellis's initiative. And comparing with other people, the BSI Fortran started mailing earlier, W5 mailing started earlier, and the J3 started earlier, and document archives. And with hindsight, it's remarkable to think that documents were distributed on paper by BCS right up to the 1997, and that cost several £100 a year but they acted as sort of newsletter on Fortran matters. So, sorry. So from 1994 onwards, we just had typically one meeting a year plus special events, and there's a list of the special events. The very successful Fortran Futures meeting, largely organized by NAG, but nominally in association with the Fortran Specialist Group. And a lot of FSG members spoke there. We had forum in London, and another meeting in London of requirements, and the 40th anniversary meeting, the Fortran Jubilee meeting. And then more recently, we've had joint meetings with various other organizations. I should just mention the development project too. In 2002, the Specialist Group Executive Committee invited bids to support specialist groups wanting to undertake specific activities, and it generously supported Fortran Specialist Group people to attend ISO standard meetings and BSI standard meetings, and that has continued year by year without too much argument until recently. For the last few years, it's been slightly more difficult to persuade them to hand over money, but money has been provided every year, but subject to reapplication year by year. And so there will be, I've got a PDF of this which will go on the website. I'll send to Harvey to put on the website, and it's with links to further information for people. So the main sources of information for what I've been talking about are the talks on the 20th anniversary, the 40th anniversary, and the two things menu on the website. And I should also like to remark on thanks to many people who've worked on, given work time and effort to the workshop. I think things are particularly due to John Gatehouse, who started the whole thing off. John Gatehouse was working for GEC at the time, and GEC had just decided to standardize on Fortran as their main language. I think we'd also like to thank Peter Crouch, who's, as I say here, the longest serving and most innovative chairman, and someone who's often overlooked because he kept a low profile, but it was Paul Samet, who was Director of Computing and Professor of Computing at UCL, who really took the initiative to ask a member of J3 to come to a users conference in Italy, especially to meet FSG members, and that really set up the link between J3 and Fortran Specialist Group. And and then further provided funds to send one of his staff to standards meetings before we really got organized with that. So that's all I wanted to say. If there's any questions, I'd be happy to try and answer them.
Thank you very much, David. There's nothing on the question panel that I can see.
Oh, good.
Just to say that
Sorry,
I'm not even able to post a question. I have no questions, but just to let you know that, at least for me, I cannot write any questions.
Are you sure?
Oh.
Because I mean, we've got them for all the other all the other
I
talks.
can only see 2 questions there. I can do the chat, but not the questions.
So there's a little box at the bottom of the question tab. John Reed's got his hand up as well. Actually, physically got his hand up. But yes, I mean I can type an example. So yeah, it's working for me.
I don't see what you're typing.
No, you're not going to see it until. Because I don't know where my own questions go, but there you go. Anyway, John, you want to say something? You're muted at the moment. John, you're muted.
But that's because you've muted me.
No, I didn't mute you.
No, you're not.
Oh, this is a horrible system. This really is. I had 2 comments. They're both about the system. First of all, I support Anton. I was trying to put a question in earlier and wasn't able to. And I eventually did a chat, which was interpreted by Ian as coming from NAG, not from me. So I don't know how you're supposed to put questions in.
I suspect the
other thing
panelists can't ask questions. That's probably why.
This really is a horrible system. And the other thing is, I couldn't see the speakers. Is that because we've set it up wrongly or what?
It's up to each
speakers while they're giving their talks.
It's up to each speaker to share their webcam. So if they don't share the webcam, we don't get to see them.
Did you mean to do that, David?
Mean to do what, sorry?
Not to show yourself while you were speaking.
I meant to do that because the first 2 speakers did the same. So I thought, I presume that was the standard way of doing things.
Well, as you can tell, folks,
I think it would be nice to see the speaker rather than just their slides. I don't know if anyone else has any comments. If I go to a lecture normally, I see the speaker. I can see the speaker.
Yeah, normally.
Yeah, I guess we're still getting to grips with the way people want things analogous to a real world or not. Okay. Well, if there aren't, did you have any direct questions for David?
No, I think Ian has a question too, or something. Ian is trying to talk.
We can't hear you, Ian. You're muted, probably.
Yeah, it says you're not muted.
No, we cannot hear, no.
I just wanted to say I was muted, so I couldn't ask any questions. The next time we do a presentation, I will show myself. I apologize.
Okay, so, well, if there are no further questions, I'll move on to my talk. And if you want to see me, you can see me, but it'll simply be me looking at my screen, basking in the glow of the liquor crystal display. I've got to make myself a presenter and be the organizer at the same time. Okay, hopefully everyone can see that.
I can only see a bit.
Can you see it?
Only half of it.
It goes rebrand Fortran, but I can't see anything to the right of that.
Let's see. I'll tell you what.
Yep.
Is that better?
Yeah.
Okay, if everyone's ready, we shall begin. So I can't really click on anything. As David was saying, the Fortran specialist group has been around for 50 years. And as you can imagine, lots of things have changed in that time. And questions have been asked about, well, how do we stay relevant, and how do we get people to continue to join the specialist group, and do they see it as relevant to them? So it's certainly true that Fortran still serves the computational science and engineering community very well. It's still a viable language. It's still an active language. It's doing its job. But unlike perhaps 50 years ago, there's a much greater multitude of languages and platforms to do computational modeling than there were 50 years ago. So, Python is, absolutely the current choice of most people these days when starting out on a computational journey. It depends what field you're in. It depends on whether there's pre-existing code. But nonetheless, Python, MATLAB, Julia, R, all these things are out there, and they're knocking at Fortran's door and pushing Fortran aside. Even if there might be Fortran underneath the hood. And that's the other thing, that a lot of people aren't aware that the original libraries might still be written in Fortran. And as Anton was talking about earlier, there's still there's an increasing requirement to hybridize code, so that you take the best of many different languages, and you might combine Fortran with C, or Python with Fortran, for example. And that's becoming much more commonplace. But Fortran still has its place. It's an ISO standard language, and that's what gets you your portability. You've got a hard standard by which you can compare against, as Ian and Jane have shown. And there's a lot of experience built into these compilers already. So there's a huge amount of development work that's in there. And I think I can't really overemphasize that, a compiler is a massive body of work. It's a massive body of accumulated experience. And that in itself is extremely valuable. So Fortran still has a value and has a place. And at the time, certainly when Fortran was around many years ago, it was the de facto language. It was the de facto computational programming language. And therefore, the Fortran specialist group was the de facto home for scientific computing at the BCS. Now, as those multiple language choices have emerged, our audience, the computational audience, is probably being left behind, because we're just looking at Fortran while the computational world is expanding out into a diverse new world. And so, as a Fortran specialist group, how can we get the message out that Fortran is there and still relevant? Because people are self-selecting. They're saying, "Oh, I'm not going to join Fortran specialist group because, well, why should I? I'm not using Fortran." And so the best way of getting people exposed to Fortran is to have a broad filter to begin with, and then you expose people to what Fortran is capable of. And we still talk, we still meet people that think Fortran is stuck in the past. They talk about dusty decks and Fortran 77 and Hollerith codes and all this stuff, all these tired old cliches. And so it's clear that the message isn't quite getting out there, that there are still people denigrating Fortran, even though it's absolutely modern, it's full-featured and very capable of challenging the modern programming issues of the day. So in order to address this, we want to change the identity of the Fortran specialist group and rebrand it as the Scientific and Engineering Computing Specialist Group. And that way we start with a broad base to begin with, and can attract people in. And if they want to look at Fortran or be exposed to ideas that might be relevant to the Fortran community, then they can. And the name, as I say, it reflects sort of the wordy presentation, but it does reflect the status that we used to have. That it was the home of mathematical modeling. This was the specialist group that catered for this. And although there are other specialist groups that talk about all sorts of programming topics, I think it's fairly safe to say that numerical analysis and understanding of floating point methods and ill-conditioned matrices, as I've stated there, that's unique to us. That's really what we do. this is where our experience lies. So there is a role to have this kind of a group, which doesn't have an equivalent in any other programming field, and so we don't really tread on the toes of any other specialist group. So this is the way we intend to go forward. We start with a broad base of scientific and engineering problems, and we embrace all the languages, but we're not going to leave Fortran behind. We'll continue to support it as it does now. I mean, some people might be worried that, are we going to lose Fortran? Well, the answer is no. We're going to continue with the standardization work and be the focal point for developments. And we'll also fund representation, or at least seek to fund representation from BCS to attend the ISO committees. And the idea is then that the broadened membership will hopefully gain experience of Fortran, and once they meet us and other people who are experienced in it. But we've always looked at other languages. Certainly in the last 10 and 20 years, we've always invited people to give talks about other languages, and we'll absolutely continue to do this. And it is possible, as I said here, that our experience, both at the standardization or just experience just as mathematical modelers, might be transferable to other languages. I mean, they should be. And it's certainly true that the more languages you know, the better and more fluent you become at programming. And I think it's good both for the Fortran community to get better exposure to other people, but other people to get exposure to Fortran. It might help people think in different ways and enable us to share our experience. So this is the revised remit that was officially approved by BCS HQ. So we're going to serve those interested in developing scientific and engineering applications or mathematical modeling of any kind. So we're not excluding the financial people or any other kind of modeling. And we're particularly trying to embrace the research software engineers who have struggled to find career paths in academia and in the research community. So we want them to feel that this is a home for them too in BCS, even if they have a separate society now. And we want to facilitate the sharing of skills and experience in mathematical modeling, and to talk about relevant programming languages, and to say, well, what's the best language? What's the best language for this particular problem? And we look at libraries, development tools, best practices, just as we always have done. Again, we're going to continue to disseminate information about Fortran, and we're going to provide platforms for discussing the language development itself. And so that's basically it. So Fortran is not being left behind just because we're changing our name, but we're going to be certainly more diverse and a bit more embracing of other languages in an official way. So the official launch, we're going to have some event in the sort of June-July time frame, 2021, pandemics permitting, and that's basically it for me. So thank you very much. Does anybody have any questions, or did I just race through that too quickly?
I was surprised recently when I gave a course at the Met Office how negative the younger generation of people were basically to Fortran. Most of the people seem to have a Python background, but were quite negative about features. It's strange in that some of the features that are in Python are based on what's in Fortran, and they seem to have got the cart before the horse. I mean, the array syntax that Python's got is Fortran based, not the other way around.
It is strange. I mean, I think we've all felt it and all seen it, that the people absolutely denigrate Fortran for no particularly good reason. It's certainly not based on any rational, or well, not seemingly any rational thoughts. But that's not to say that new languages don't have their place and have much better features in certain areas. I mean, I program in Python when it's appropriate to do so, and a lot of the time it is. I mean, Fortran's not for everything,
I mean, a few years back, you might have said Java there and not Python, and you don't
Yeah,
hear that so much now. So,
no,
you
thankfully.
know, these things tend to change.
And there's certainly a prevalence of larger platform-based computing. So, or perhaps using sort of wrappers. So, like TensorFlow, for example, is becoming a very popular environment in which to develop algorithms. And people obviously use MATLAB and other systems like that. So the programming is much higher level.
I think broadening the remit of a group is definitely the right thing to do, and I think the direction you're taking it in is a good idea.
Thanks. I can't see any questions from the panel, from the sorry, the attendees. Don't know if anyone's got anything. I've lost the hands up. No hands up.
I mean, one thing occurred to me. Sorry, John, was
Harvey,
that
go ahead.
they will be. It sounded like there will be publication of this event on YouTube in chunks. So it might be good to mail the membership and point to that particular talk you just gave as an introduction, and solicit any feedback that people have. You know?
Yeah, absolutely. I mean, we're obviously here for the members. We're here to serve the existing members and to bring new members in. So any ideas that they might have will obviously be gratefully received. I mean, this is a volunteer organization. You know, none of us here are paid, and we don't have dedicated time to this. So I think that has to be remembered. And particularly during this COVID era, I know lots of IT staff have been snowed under. Here's some questions. So C++ is widely used. How does that fit in? Well, it does fit in if people want to talk about it. We've certainly had talks about C++ used in numerical applications before, and I don't see why we wouldn't do that in future. What else we've got? I'm really struggling here with this system. Well, John, sorry, yeah. I think you're muted, John.
Yeah, John, you're muted.
It says self-muted here.
Sorry about that. Yeah, we don't have any feel for the audience. We can't see any of the audience, so we don't know who they are. For instance, it'd be interesting to know if we've caught any from abroad.
Yeah, Bill Long's here.
Bill Long's here, yes.
Oh, excellent.
You should be able to see the attendees panel. You should be able to scroll through that.
Oh, can I?
Yep.
It only shows only shows us, not.
No, John, I think we'll have to learn about this tool, but it very much distinguishes between someone who's attending and us as a group. So we don't see those things. You are, because you're an organizer, you're seeing far more than we are.
No, you should be able to see.
So we don't see questions, and we don't see other people other than the small group of organizers and presenters.
Okay.
Like it's just the way GoToMeeting set up or it works. So it's been a bit of a confusion for us as we've gone by.
Well, that's true.
I've never seen a hands up facility either. You?
No, I can't see that.
Yeah, so apologies, folks. This is obviously our first time with GoToWebinar, and we're still learning its features and the rigmarole.
Jane, we cannot hear you.
Yeah, so Gary can say he can see the attendees panel. Everyone should be able to see it. I mean, I don't see why.
No, I don't see it.
No.
I don't see it.
Don't see why you can't.
It says attendees 22, and then it says staff 7, and I only see those 7.
Yeah, but that's a tab. Do you not see attendees 15?
No.
No.
It says attendees 22 out of 1,001.
Yes.
I wonder where the rest are.
I don't think there's any
There's
tab.
names of staff. We're all staff. I can't see any names of the non-staff people.
Yeah, perhaps only organisers can see it.
Like I said, I think that's the problem. Your role is different, so you see different things. So I think you see something different from us, and that's different from people who are attendees.
Apparently so.
Which is confusing. And one thing
Well,
we
it's not-
don't get, we being presenters, is questions. Or panelists.
But yes, but okay, but there are no questions that aren't directed to you. So let's see. Okay, sorry folks, this is not particularly interesting while we laterally get to grips with GoToWebinar.
Well, we are going to be using this in the future, so I think it is important that we.
Well, we might not be because BCS are getting a Zoom license. So
Well, my vote will be for Zoom. I think it's much nicer.
yeah, we might never be using this again.
I certainly have found Zoom relatively straightforward.
Okay, so I don't know what you did, but my panel has completely changed, and it now has all the things that I've been missing all the time, including questions and attendees. So it's quite, who knows?
Yeah, so questions get assigned to individual people.
Yeah, Harvey's an organizer now.
Yes.
Yeah.
So let's see. Yeah, so Gary's making suggestions. Absolutely. I mean, we all use Teams, WebEx. We've used all. This is the first time any of us have used this platform.
Yeah, so that explains it all. As soon as I was changed to organizer, all my panels changed, and I got far more things than I had the first time. Whereas I had a selection of those things before. So that's why it behaves like it does.
Yeah, you would think the panelists would be able to get access to those things.
Okay, well, I mean, we'll sort it out next time, or we'll choose a different tool.
Absolutely. So sorry, folks, for witnessing the learning curve that we're all on. But there you go. This was the BCS approved tool. So there's a question about development tools. What functionality would be deemed most helpful by the panel? But the development of tools. So I should be able to. It would also help if my screen wasn't so tiny. Okay, so the questioner should be unmuted now, so should be able to.
Oh, hello.
Hello.
It's Themos Tsikas from NAG. So, as you may know, we have the NAG Fortran compiler has a few tools in it, and I was just would like to get some feedback about what tool would you consider to be most valuable that doesn't exist. One current idea is a common block converter with its difficulties. So I'm looking for ideas like that, so we could prioritize and consider what to do next. There used to be a lot more in the tools around, but they don't seem to be available anymore.
No, most of them seem to have disappeared. I mean, we tried keeping track of them in the Fortran resource file, but most of the companies involved with it have disappeared.
Okay, thanks.
Jane, you okay?
No, no, I'm muted. Oh, right, that's okay. Yes, yeah. I was going to say a traceback facility.
But that's compiler dependent, isn't it?
Yes, yeah.
Yes, but he's talking about the NAG compiler now.
Yeah.
No, I was thinking of a compiler independent tool, source converters, for instance. We have a traceback facility in the NAG compiler. I'm pretty sure it probably exists in others. But it just what Anton was speaking about earlier, that was very close to to my heart. I can't bear to see code like that in 2020 anymore, and something must be done. I don't know what, but there is no call for real star8 anywhere anymore.
You should have seen the code we had a little while ago, Ian and I.
And
Fortran 66 with computed gotos.
Right.
I use the source form converter in the NAG compiler. I find that very helpful.
Yeah, that's very good.
Picking up old codes.
Yes, and in fact, I have the enhanced polisher, which is able to add declarations. I just tried it out with the ballistics code from the Cold War, 1962, written in Fortran, original Fortran, as far as I could tell. It didn't even have a function or any subprograms at all. And with the exception of the sense light statement, it went through the NAG compiler, no problem. So,
I mean, I think there's a couple of issues. One is, can you make money out of it, right? Can anyone make money out of doing that? Because if they can't, getting it done is going to be quite difficult. And we're in a world where people might want to write a plugin for an IDE, but they'll want it to be free. And the other problem is standards conformance. So a lot of tools have existed in the past, and they might have been really great for a while, and then they don't stay up to date, which makes them useless. Because if they don't work on your code base, you just don't want to use it. And these tools have existed. I mean, there was a thing called Nagware. I mean, I don't remember how far back that goes, which I think was a range of tools that, whether it was just analysis of a Fortran code base or it was a transition to something else, I don't remember the details of it. So yes, it would be nice if you could go through some dusty decades we've called code and then convert those all to modern idioms, or spot all these extensions and automatically fix them. But that sounds like a really hard thing to take on and keep up to date.
Well, we're talking about the NAG compiler itself at the moment, which is a commercial product which has to be bought. So I think the question is asking, would more tools make it more attractive?
Jane and I have great difficulty persuading people to buy the compiler. I mean, one of the things that I find very difficult to understand is a week of your time chasing bugs. I mean, the NAG compiler, you buy the NAG compiler and you've recovered the cost of your lost time. And that's one of the things that I find distressing.
yes, I think that's what I'll be trying to convince people. I mean, a visit to Compline Fortran will show, how many hours were wasted on a thing that could have been picked up by the NAG compiler in a second. So I just do not understand, I guess, how people justify keeping their old codes full of bugs running. But the idea of having tools perhaps separate from the compiler. So you might be able to get the compiler, and some tools might work unlicensed. So you'd have free access to the tool, but if you wanted to get more information, perhaps you. So thinking of things like that, but trying to understand what would actually make a big difference in getting these old codes more reliable, essentially. Now, maybe there's not a big market in old codes, and we should focus more on the use of modern Fortran. And of course, we do that as well. But any pointers to what would you consider, a very helpful tool would be appreciated.
I could perhaps answer Harvey's point. NAG used to market a set of tools, but it wasn't commercially successful, so it was discontinued. But some of the tools have been quietly inserted into the compiler, including the one I talked about, which is the source form converter. So that's what's happened to the NAG tools, basically. They weren't successful as a commercial product.
Yeah. From what I remember, it was funded externally by something like EPSRC or something. There was something, there was research money available that NAG took advantage of, but my memory of it is a bit vague.
My memory is quite vague because I was not involved in the compiler in the 90s, so I vaguely remember the situation as well, but I couldn't tell you exactly what the arrangements were. We're definitely involved in a great many funded projects. We still are.
Mm-hmm.
But as John said, yes, some of the tools have been incorporated into the compiler, and more will be, I expect.
Often companies or organizations have an Intel license bought by somebody who doesn't really have anything to do with Fortran. So that's what they use at work, and then at home they'll be using sort of G-Fortran. It's quite hard to persuade them to buy the NAG compiler as well.
I've just noticed that Bill and Gary Harding both have difficulty speaking. I'm still here working on enabling the microphones. That's Bill. And then Gary said, I can't unmute myself.
Okay, Gary's through.
Yes, I can speak now. Thank you. Really, all I wanted to say earlier was I supported the change in the resolution, which I think I put into the chat anyway, and or the organisation's name. But I said I also had problems in like seeing any of the attendees or any of the other information as well, which personally I found more difficult. I think it'd be nicer to have a forum that allowed you to see who was there, at the very least see their names, and also, if not their pictures.
Yeah, we'll definitely learn from this, and that learning might be not to use it again.
Yeah, it says that Bill is self-muted to me.
Yes.
Oh,
So Michael's unmuted if he wants to say anything.
I was just going to comment that although originally NAG's compiler was extremely good and that its standard support was better than any other compiler, shortly after Fortran 90 came out, it does seem to have been slipping in recent years, in particular things like OpenMP 7 deconstructions, which have been around for rather a long time now and are quite useful in getting code up to speed on modern processors. NAG still throws out as an error because it only understands OpenMP version 3, not 4.0.
Well, that is true. I think with OpenMP, it has not kept up with the developments in OpenMP, but there will be an extra version, and I think SIMD is going to be in the next version.
I think people should be demanding that do concurrent is properly implemented using the existing hardware and doing true concurrent calculations whether it is implemented under the hood as OpenMP or something else.
So Sam Ellis had his hand up. Sorry, Sam.
Yeah, there's a couple of things on the NAG tools. It was originally called Toolpack because I implemented it on the VATS VMS at Shrivenham, and it was about 1986 or 87. One of the interesting things about do concurrent is it's a thing I meant to mention to Ian and Jane. In your tables, it says that Intel actually implements do concurrent. Well, it does and it doesn't. Depending on which version you use, it won't compile, and in other versions, it tells you it doesn't like it when you declare the variable in the concurrent loop. It tells you it's not used. So it's a bit of a pain to use because you either use a compiler where it doesn't work, or a compiler where you get lots of errors.
Yeah, I mean, the information in the table is based on that provided by us by Intel.
Intel,
basically, yeah. The version number at the top is the key. So what happens before that? You know, Jane and I can't really comment. But if you find,
I think go on.
Well, you said different versions, so it would depend on the version of the compiler that you're actually using.
Yeah, I think it may have matched what was in your table. It's just that as they upgrade the versions,
yeah,
they mend some things but break others.
Well, that would just be a bug that you applied to Intel.
It's not. I just ignore it. It's just telling me that I know it. It's just telling me something's not being used. Well, I know it is.
Well, you should still file it as a bug.
Yeah.
I mean, that's the comment Steve Lionel made, basically, when he was still working at Intel. He said, if there's something that somebody claims should work, you just file a bug report. And that was the comment he made about the Intel compiler. And we'll sort it out. And that's Steve's comment.
Yeah, I just don't find the Intel system easy to use. Filing a bug is almost half a day's work.
You can still send a message to Steve.
Yeah.
Yeah.
He's still friends with them. Yes, he'd pass it on, I think.
Yeah.
As long as he doesn't pass it on to Stan. Sorry about that.
Well, perhaps a question to John. There is some extensions to do concurrent coming up in the next Fortran standard, which I think are meant to make it work quite well in GPUs. Is that have I got the right idea here?
Well, there were some corrections in 2018. Late on, there were some changes made. Is that what you mean?
I think there is some items in the 22X, so the forthcoming.
Well, maybe Anton could answer that. I've not really been following 20X very much. I've been focusing on interpretations more than the new standard. I've done so many now, I'm rather tired of thinking about new features. Anton, can you answer that, possibly?
Not really. I need to double check. There are some features to do with locality clauses, which we uncover further and further holes in the specs. Beyond that, I don't remember right now. And there was also probably you remember better than me, there was a prolonged discussion on Complang Fortran about what concurrency actually means for that construct. And there was a surprise to some people when they realized that do concurrent does not guarantee that the iterations of the loop will be done concurrently. The semantics is subtly different from that. So the rules as in the standard could prevent the do concurrent construct can still work, but certain constraints can be not satisfied, so that the iterations cannot be truly concurrent in some cases. So there might be some further work on that to strengthen the specs to enable true concurrency.
If Bill Long is online, maybe he could answer.
Yeah, Bill's just replied.
Oh.
The 22x change to do concurrent is to add a reduction clause. So it's in the questions bit. If you, I don't know if we can see it.
No.
Yeah, the reference is given in Anton's report. It's US Proposal 20.
Yes, that's right.
Okay, I don't think I can see any more questions. It looks like we're actually going to end on time as well. Okay, I think I'll just wrap up there if there's nothing else. I don't know if Bill's self-muted, so I don't know if he wants to chip in.
Oh, sorry.
But anyway, yes. So I'd like to say just thanks to all the speakers for their presentations this afternoon. I'd also like to say thanks to the audience for being there and for bearing with us and through the little technical hiccups. We'll, as I say, we'll get better next time. So it only remains for me to say just thanks again and cheerio, and catch you the next time, which is hopefully there'll be an event in the summer. If not, it might even be something in between, but watch this space. So thank you very much.
Okay. Thank you, John.
Yeah,
Thank you,
Yep.
John. Thank you, everybody, and goodbye.
Thank you.
Cheers.
All right.
Bye all. Thanks.
Thank you.
Thanks, John. Bye-bye.
Bye.
John?
Yep.
I think I managed to unmute Bill. I know it's a bit late, but I don't know if he wants to say anything.
Well, oh, there he is. He said he was self-muted on this, but anyway. Yeah, he's self-muted, so he doesn't. I guess he doesn't want to say anything.
Yeah, fair enough.
Oh, we have some John just speaking at the moment. But not Bill. Bill.
Yeah, I think we're. I think that's it.
Yeah.
I think we're.
It seems so.
Yep.
Okay,
Yeah, I think the next time we use this, if we do use it, we'll have to use a little cheat sheet for both the audience and ourselves. I mean, no one seems to be using the chat, even though it should be available to them.
I tried to. Yeah.
Yeah, it was hard for me to understand it because the initial side panel I had only had a chat that was only for presenters and organizers and panelists. So what I don't know is what a normal attendee would have got, whether they got a chat that was attendees to organizer. And then when I got organizer privilege, I was then able to see many more things. But the missing piece at the moment is I don't know what that panel looks like for an attendee.
Yes, exactly. Yeah. I mean, I was told by Mandy that people can't chat to each other, but they should be able to chat to us. So
it might be that the chat and the questions go to an organizer who can then reply and make visible that. Because it looked to me like when you answered some of these questions, it appeared in the chat window, but I didn't see anything until that point. That was a bit
Paul
strange.
Hollister had his hand up.
Yeah. I was on a comment about the chat window. It seemed very delayed and only had general audience questions rather than direct-to-speaker questions.
Yeah, I think there are two windows. There's a chat window and there's a questions window, and that I don't know if people are seeing both.
So on mine it's questions/chat. So I've only got one window. Single window.
Yes, we've got two. Well, we've got a chat window and a questions window. So that's good to know.
Yeah, and when
I've only got questions.
I've got questions and chat. But why can't I see all the attendees?
Well, I can now for some reason. It just popped up a few minutes ago.
You need to be an organizer to see that.
Ah, right, okay.
There is an option that says attendees can view attendee list, and it's ticked. So.
Well, I can see the attendee list.
That's come on. I can see that now, John.
Well, in the attendees list, there's a column with a question mark at the head, and then opposite two names now, there's a question mark. But
yes, that's because they've asked questions that haven't been officially answered, marked as answered.
Yeah, well, but you see, when I was not an organizer, the attendees tab had staff in it. That was the only thing that was in it. When I changed to an organizer, it had staff and an attendees tab that then let you see attendees.
But why don't they let staff look at attendees? That just doesn't make any sense.
Yeah, well,
I mean, you're a panelist, right? You were marked as a panelist.
Yeah,
remember, so it is the BCS.
Well, it's GoToMeeting, right? So it could be that panelist means the organizer has a special selected set of attendees who are in a panel who can communicate with themselves, and it's not really a privileged thing. That may be all there is to it.
But they should be able to receive questions and.
Well, you'd hope so, wouldn't you?
Yeah, you would hope so.
Like a bit confusing.
Well, Ian was staff, and now he's an attendee. Ian Chivers.
He's what?
Ian Chivers was staff, and now he's an attendee.
Right,
been demoted.
He must have left and.
Left.
So I think we need to have a session with somebody who understands this, whether it's the BCS groups person or not. And then if we believe we can use it again in a way that's reasonable, fine. But if not, we need to do something simpler.
Yep.
The other thing is I've dialed in, so I'm not using my computer audio. Don't know if anyone else has tried that.
No, it was an option, certainly.
Well, I'm on a computer now with no webcam as well. I'm just dialing in and watching the video on a PC.
It's good to know that works.
So, John, can you feed this back to whoever has provided?
Yes, yeah, I will. In fact, I saw this morning that there's I don't know if you look at I can't remember what it's called, Basecamp, the Basecamp facility that BCS uses.
Okay.
There's a bit of chatter that there's a lot of disgruntlement in there. So
How's Bill got to be a presenter?
Yeah, someone's elevated him to a presenter, but now he can see the chat window.
So only presenters can see the chat. Is that the? I mean, that's crazy. There needs to be a chat window for attendees to feed stuff back. I mean, that explains why no one was using it. Other than
So
ourselves.
I could see a few of the questions, but not all of the ones that were being answered.
Yes, so they need to be marked either for everyone to see or for the individual to see. It's a bit
these are marked.
silly.
So it says audience question.
Yeah, it's a bit silly. I must say I don't like this. I don't like it. It's too inflexible.
Mm.
I mean, it's just too clever because I think what was happening is we brackets panelists were asking ourselves questions which were getting answered to everybody at the same time as attendees were asking questions which were getting answered. But each set of people couldn't see the questions from the other set.
Yeah.
So it was a bit confusing.
Yeah.
At least with Zoom, you have one chat window.
Yes.
And everyone can type something into it. And what I was hoping to do with Anton was if you have one person talking and then someone else knowledgeable can just watch the chat and either answer in the chat or interrupt the talk to say it's an important question. You know, it works quite well that way, but that's not really possible here.
Well,
The
Paul
other thing on my
Thomas
chat window.
Yeah, sorry.
So my chat window, some of the questions say answered verbally. I don't know whether that's something.
Yeah, I had to type that in. I had to type that in to clear the question.
Oh, okay.
Otherwise, it doesn't seem to get done. But Paul Thomas put his hand up, and I didn't see it. I mean, it doesn't flag it. Doesn't seem to flag it up anywhere, unless you keep an eye on the attendees list. But it's absolutely microscopic on my screen.
Especially when there's be 1,000 attendees.
Yes.
Rather than 10.
Yeah. And I've got a 4K screen, so I mean it's tiny.
It's hard coded, 16 by 16 pixels. Can't go wrong. Foolproof programming.
Well, it got us there most of the way. So.
Yeah. Yeah.
And the rest looked like it was designed by a massive committee, and everybody said, "Oh, I want this button of this color here," and someone said, "Oh, yeah, okay, but I want this panel here," and in the end, it's everything and nothing.
Yeah.
I think that's what's so nice about Zoom. They kept it simple.
That's true, yeah. That's true.
Yeah.
Yeah. So, I mean, as Mandy said, Zoom will be available, I think, in October. So.
What, 2021?
Well, she said the only delay at the moment is they're just getting training on it, to make sure that they know how to help people.
Oh,
with
right.
It, so.
I think we picked it up in 5 minutes, so it's not.
Yeah.
Anyway, it's time to go. There's a rugby league game to watch.
Oh dear.
Bye.
Okay.
Cheerio. Thanks again, everybody. Cheers. Thanks.
Okay, bye.
Bye-bye, bye-bye. Bye-bye.